Okay, let's look at a few others here on Trig Chapter 1, Practice Test 2. The first one, we have 2a to the fifth to the third, okay? The whole thing's being raised to the third. So that means I have a 2a to the fifth times another 2a to the fifth times another 2a to the fifth. All right, now we can write that out if we need to as 2a, 2a, and one more. You should start being able to sort of see, oh, I have 15 A's there. But again, if you mess this up, you're best to just always make yourself write it out. 2 times 2 times 2 is 8. And then again, you have 15. So it's 8a to the 15th for number 5. Number 6, into the fifth, into the fifth. Well, again, in my brain, here's what I'm seeing. I don't have to write it out, but that's what I'm visualizing when I see into the fifth. I think of that. Into the fifth, I think of that. And then I can easily see, oh, there's 10 of them. I'll get into the 25th there all the time. Into the third raised to the fourth. Well, I think what it means. Into the third times another, times another, times another. So you can see 3 n's, n, 3 n's, n, 3 n's. That didn't take that long to write out. That's into the 12th. We got one more down here below. Okay, here it's n squared times y squared. Well, I can't really do anything there, but this is a bunch of adding. Notice the other problems had no adding in there. It was just a bunch of multiplication up there. So I'm combining like terms. I'm like, hey, you have one n squared y squared. Do you have any more n squared y squareds? They're like, oh, we have 9 of them here. So how many total do you have? You have 10 n squared y squareds. And then you have this into the third y plus another one. So if you have one and another, you have how many? 2 of those n third y's. That's just combining like terms. Things that are exactly the same can combine. Number 9. Well, if I look at this, it's negative 5 y times 3 y. Negative 5 times 3, negative 15. Y to the 8th. There's your answer for number 9. Number 10, it has a binomial, meaning there's 2 pieces. There's a piece here and here inside parentheses times a piece here and here. Okay, so it's a binomial times another binomial. So what I'm going to do is I'm going to distribute the 2x through to each piece, and then I'm going to come in here and distribute the 1 through to each piece. Some teachers call it FOIL. I don't like that because it is only good for a binomial times binomial. Won't do us any good when we have a binomial times trinomial, which we'll see in a minute, or a trinomial times a trinomial. So just know I have to distribute each piece through. So 2x times 3x, well, 2 times 3 is 6, and an x times x is x squared. 2x times the 1 is minus 2. 1 times the 3x, that's 3x. And 1 times negative 1 is subtract 1. Now, putting together pieces that are the same. Now, one thing I messed up, I don't know if you noticed, 2x times that 1 was minus 2x. I quickly realized, wait a second, sometimes, usually, pieces will combine. And when I saw that, oh, wait a second, something's not right. Something said, hey, you made a mistake. So now we see 6x squared, lose 2x, gain 3x. It means you gained an x back. Lost 1, minus the number 1. We have that entire 5x plus 1 being squared. That simply means you have the 5x plus 1 times another 5x plus 1. So now I'm going to do exactly what I did above. The 5x is going to get distributed through to each piece. And then the 1's going to get distributed through. So 5x times 5x is 25x squared. 5x times the 1 is 5x. Now I'm going to distribute the 1 right here through to each piece. 1 times 5x is 5x. 1 times 1 is 1. Putting them together gives me 25x squared. The x's go together to give me 10x, and then I have the number 1. So often, kids will always take this and go, oh, that's 25x squared plus 1, and they miss this middle term here because they're like, oh, can I not just distribute the squaring through to each piece? The answer is no. You need to think what it means. All right, number 12. Here's an example of a binomial times a trinomial. So we're going to have to distribute the 4 through to that piece, and that piece. And then we're going to come in and distribute the x through here, here, and there. So let's do that. That'll give us 6 total pieces, what we call terms, and then we'll, boom, combine like terms. So 4x squared times an x squared, that's 4xx times xx, x to the 4th. 4x times that 2x, 4 times 2 is 8, x squared times an x is x cubed. 4x squared times negative 1 or minus 1 is 4x squared. Now let's do the x through. X times x squared, x cubed. X times that 2, minus 2x squared, and then minus x when I distribute. Now let's put together. There are no other x to the 4th. There's an x to the 3rd here, minus, wrong spot, Cecil, plus an x cubed right there. So let's lose 7 of them. And then you have an x squared and the x squared. Lose 4, lose 2, you've lost 6 of them. And then at the end, by itself, you have minus an x. There's problem 12. 13 creates confusion for kids sometimes. I'm squaring this whole thing, which means I have a 2n squared y cubed times another one. And then I'm adding this 3 piece. Now, notice it's a 3n times an n times a y, which we'll just write it out for the fun of it. And nothing else to do. So here, 2nny, 2nny. I know most of you might not need to do that, but again, do it if you need to. 2 times 2 is going to give us the 4. N to the 4th. Y to the 6. Plus, what do we have over here? 3. N. That's n to the 5th. And then we have y to the 6th. Are these the same? They can only be added if they're exactly the same. This is an n to the 4th, y6. That's an n to the 5th, y6. They're not the same. It's like trying to group people when you put Bill and Billy in the same group. They have different names. You can't do that. Nobody's going to like that. All right, let's look at number 14. Number 14, negative 5x to the 5th times negative 4x to the 5th. Well, it's negative 5. X, negative 4, x. Negative 5 times negative 4 is positive 20. How many x's do we see? 10 of them. So it's then x to the 10th. All right, we're going to stop there. We'll pick up on problem 15 in the next video.